Hello students. In this video we will go over chapter 11, time series and forecasting. Time series analysis is used to determine what type of trend exists in the data, if there is a trend, and what type of trend. Four components to a time series: secular trend, cyclical variation, seasonal variation, and irregular or kind of a random variation. So we'll go over some of those four components and look at some examples. So the secular trend, smooth long-term direction of a time series. There appears to be a slight upward positive trend in this data. So that's what we would mean by the secular trend. Cyclical variation, this is like the economics cycle that you would study for business, where you have periods of recession, depression, periods of prosperity, contraction, basically still showing long-term upward trend. But as you can see that sometimes it increases, sometimes it decreases. Decreases during times of recession, then it recovers, then it contracts, ups and downs. That's the cyclical variation. Rise and fall of time series over periods longer than 1 year. Seasonal variation or patterns of change in a time series within a year. The patterns generally repeat themselves. So in this case, we have 3 years of data measured by quarters for each of those 3 years. And as you can see, quarter 1 increases in quarter 2, falls in quarter 3, then increases in quarter 4, then of course increases again in quarter 1. And you can see that in all of the 3 years of data we have, that quarter 3 has the lowest sales. Quarter 2 has the highest sales. Quarter 4 rebounds from quarter 3, so whatever the quarters are, whatever this product is, it means that sales are peak at quarter 2 and they fall off in quarter 3. So we can use various forecasting methods to determine what are going to be the sales, perhaps, in the year 2014 for each of those 4 quarters. It's a process that involves addressing the seasonal fluctuation, measuring that, and then using that to predict or forecast quarters in subsequent years. The irregular or random variation can be divided into 2 groups, episodic and residual variations. Both are unpredictable. The episodic fluctuations can be identified and then removed, and then the remaining variation, the one more caused by randomness, is the residual variation. As I've said, they are chance fluctuations, unpredictable, and they cannot be identified in terms of the reasons why something's happening. Sometimes, for example, sales or production is just down because of other unpredictable variations or random fluctuations. So this, as I said, in this chapter we look at trying to determine what type of time series exists. We analyze that, and then we look at we look at a few forecasting models in this introductory look for this course. So I'm not going to get in depth in terms of analyzing or determining which one we should be using. We're going to look at the process of how to use two broad types of forecasting measures. So as it says, the moving average is useful in smoothing a time series to see its trend. Basic method in measuring the seasonal fluctuation. So to use the moving averages for a time series trend analysis, the data should follow a fairly linear trend and have that definite rhythmic pattern of fluctuations. And it is used to reveal any trend and seasonal fluctuations. Let's take a look at this example. Here is some seasonal or variations here. They developed a 7-year moving average, and we look at different types of moving averages, but a moving average is just looking at the past or historical data, averaging out that value to be used as the forecasted value in the future. So we can see that there is a trend. So that's the purpose of time series analysis. Most of our work in this chapter, short chapter, is going to be looking at understanding 2 different types of forecasting methods. So the moving average generally can be any term, 3, 5, 3, 4, 5, 7, whatever time we want to build into the moving average. Of course, that's based on the specific data example and the situation that we are working with. Generally, it's used if there is no trend, positive or negative. So no trend exists in this data. The data is kind of would be more horizontal, would be more would have generally very little slope to it. And we can look at a regression trend, linear trend. This is very similar to the work that we did back in chapter 9. This is generally used if there is a linear trend has been determined, is evidenced through graphing the data. When we have developed different types of forecasting methods, we can look at to determine how accurate the forecasting methods are. And we do that by looking at past or historical data to see how well our forecasting method would have predicted values in the past. If it had more accurately predicted values in the past using our forecasting equation and method, then we have a little more confidence in how well it will predict values in the future. So there's 2 methods that we use to evaluate that. One is the mean absolute deviation, and the other one is the mean squared error. The linear trend, this is very similar to chapter 9, where we have the intercept slope x, but basically in this chapter it's going to be written as a would be the y-intercept plus b, the slope, times the time element. So if it's quarter 3 times series 4, that's the value we would place into for that t value, and then we could use it to predict a future value. So we're going to look at this example. This is production values based in 15 years of data or so. We're going to compute a 3-year moving average. We're going to compute a 5-year moving average as well. Basically, a 3-year moving average is we look at the last 3 years of data to predict the next time period. 5-year moving average, we look at the past 5 years worth of data to predict that value in that 6th year. We can also develop a linear regression. It uses a slope and y-intercept from the data. The slope, as we could calculate using a regression tool or just a slope and intercept function. Slope calculates out to be 0.747. Intercept is negative 1486.6. And a couple ways we can go through this linear regression process, but for the sake of this course, we're just going to be looking at these 2 different types of models. Moving average, maybe a couple different time series, and then a linear regression as well. So we're looking at a really basic example of production versus year. It may not be the best model for the moving average or for linear regression for that matter as well, but the calculation process would be the same. So if we graph this data, we've graphed year versus production, it looks like this would be the data. So there's 4 years of growth, 2 years where it falls, and then growth again, 2 years of falls. So there's some general upward trend. We can actually determine the trend line. We can go for a linear trend, and we can see that there is a trend. And we're going to develop, go through the process to determine what the forecasted method would be based on each type of method. So each method, let's go back here, sorry. Let's determine the forecast for the year 2014. using both of these methods. So here is our Excel example sheet we're working on. This is our data that we have here. So what we'll do here is we will develop, using the MAD sheet, it doesn't matter what sheet we're on, but we will develop a forecast for a 3-year moving average. And this is basically done by calculating the average of the last 3 time periods. And that is what our forecasted method would be based on that model. Whereas a 5-year looks at the last 5 years of data. And that is a value here. So in essence, what we did for all of these values here is we did the same. 6.3 is the average of these 3. 8 is the average of those 3. So that's why that's the moving average concept. As these values move down, as we move down the time series, for example, 6 would be the average of 10, 5, and 3. You know, those values add up to 18. 18 divided by 3 gives us 6. Same thing with the 5-year moving average. 6.8 is the average of the first 5 years of data. 6.4 is the average of the next group of 5. So we can develop these moving averages. We can also use the, we can calculate, let's just put these values here, slope and intercept. We can calculate, use Excel to help us find the slope. Slope is known y's over all of the x's. The intercept, same thing, the y values first, what we are predicting, and what we are using to make that prediction. Oops. What happened there? There we go, comma, and there we go. There is the intercept. So if using that equation, we can develop our predicted value. So the slope, or the intercept, plus the slope times the year 2014 gives us this value here. Now there's going to be some rounding differences with this value. If you round it slightly different, you might get a value closer to 18, for example. So these are the 3 predicted values. The question becomes, over here, is which each method has resulted in a different forecast, and which is the best forecast. Determining which method is best is based on 2 evaluation techniques. We can use the mean absolute deviation, which is basically just the difference, the absolute difference, so ignore the negative signs. The differences between the actual y and the estimated y, and MSE is the squared difference between the average of the squared differences between actual and estimated y. Generally, the forecasted method has a lower value, is generally preferred. And you would choose one of these. We're going to go over both of these, but generally a researcher is going to have one that's more preferred. And there are other methods to determine the accuracy of forecasting methods, but these are the 2 that we will focus on.